Good day, ladies and gentlemen. Today we're going to talk more about trigonometric identities. This particular video is going to jump up in the level of difficulty from trig identities day 1. So hopefully you can take some good notes. Keep in mind you can always pause the video or rewind the video. The assessment over Unit 10, Lesson 1, which is the beginning of trig identities, will be a Google form where you will have to repeat all of the steps for these proofs will be given, and you will have to choose incorrect steps. So if you take good notes during these videos, you should do really well on the assessment. If you do not take notes, you will have no idea how to do the assessments. Just giving you a heads up. So let's start. This is the end. This is example 4. This is the Unit 10, Lesson 1 notes. This is Unit 10, Lesson 1 notes. And we're going to finish up these notes. We had one more example. And then we're going to jump into some Unit 10, Lesson 1 assignment that was optional, but I'm going to do that just for some added practice. So here I have this identity of the cosecant A minus cotangent A is supposed to equal sine of A divided by 1 plus cosine of A. So let's jump into this proof. The first thing we're going to do is we're going to start with the left side, and we're going to write everything in terms of sine and cosine. And we know that cosecant A is 1 over the sine of A, and we know that cotangent of A is cosine of A minus the sine of A. Keep in mind, do not write your right side because we're going to go here, dot, 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 and end up with the right side. So it looks like right away what I'm going to do, I have like denominators here. So I'm going to add these two fractions. I'm going to write this as 1 minus cosine of A. And I really like the idea of how we're going to assess this with the Google form, because these proofs can be very difficult to generate. But if you're given the steps, I think it's going to be easy. I'm at school and that's the bell. I think it's going to be easy to pick out the correct steps versus the incorrect steps. So keep in mind where I want to go. What I'm going to do, the next step here, what I'm going to do is I'm going to take this guy just because I know where I want to go and because I've done this proof multiple times before. I'm going to take this rascal. How would you know how to do this? Just practice. And I'm telling you this is going to be kind of difficult, but you'll be able to see the correct answers. What I'm going to do is I'm going to multiply that rascal I'm going to multiply this dude by 1. Get my pen to work here. 1 plus cosine A divided by 1 plus cosine of A. Okay. If I do that, and now if I look at the top very carefully, this is 1 minus cosine times 1 plus cosine. This is the product of conjugates. This will be 1 squared minus cosine squared A. This is the difference of squares. Factor the difference of squares is going to be 1 minus cosine, 1 plus cosine. And then the bottom, I'm just going to leave that. I'm not going to multiply that out. I could, but I'm not going to. Why? Because I know where I want to go. Okay? So now, the next thing I'm going to do is I'm going to use the Pythagorean identity, And I'm going to realize that this top thing here, 1 minus cosine squared, that is equal to sine squared of A. Look back in your notes from yesterday. And so now I have that, and you're going to see in a minute why I did not multiply through the bottom. I have to walk through this video a couple times. Oh, and look what I have here. I have sine squared divided by sine. One of these signs will cancel. Sine squared divided by sine is going to be sine on top divided by 1 plus cosine A. And guess what? That is what I desired. Sine of A over 1 plus cosine of A. This is as desired. Okay? Very good little proof there. You might have to walk through that. There's a couple steps. Now what we're going to ask you on the Google form is, this is a correct step. We're just going to ask you which correct step. Bam, 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 bam. And not all of these proofs will be on that. Bam. Can you pick out an incorrect step? Okay, so now we're going to jump over here. So we're going to do the assignment here. A couple of the problems off the assignment. I believe we posted this, but I'm just going to go through this. This is optional. Might be a good idea to walk through some of these problems. And a couple of the first ones are pretty easy. So I want to take this particular identity. I want this left side and show that is equal to cotangent. Step number 1 is take the left side, write it in all terms of sine and cosine. So this is going to be 1 over sine of A times, oh my goodness, cosine of A over 1. Oh, and what is that? That is actually equal to cosine of A over the sine of A, which does indeed equal the cotangent of A. This one, ladies and gentlemen, was easy peasy. Oh yeah. All right, let's jump to a little bit more difficult one. This rascal right here, I want to show that this right side here, this left side, is equal to cosecant. Certainly doesn't look like it. I want to notice that this is cosine of A times the sum of tangent of A, cotangent of A. So make sure you don't make that mistake. So I'm going to, step number 1 is write everything in terms of cosine and sine. So I have cosine of A, and I'm going to put a big bracket here. And I know that the tangent of A is sine of A over cosine of A plus cosine of A over sine of A. That's cotangent. Don't write the right side. And guess what I'm going to do? I'm simply going to multiply through by cosine. I'm going to take and multiply through by this cosine. Cosine times sine over sine is simply going to be sine of A. Don't write that in yellow, please. Bam. This times this, the cosines will cancel. This times this, I'm going to have cosine squared A over sine of A. Okay, keep in mind where I want to go. I want to end up at 1 over sine of A. So now I have, which is a single thing, I'm going to add these fractions here. And how do I add these fractions? I have to get like denominators. Right now, that guy has a denominator of 1. So what I'm going to do is I'm going to multiply this by sine of A over sine of A, which is in 1. So put that over sine of A so I can add them. And I'm going to, let's get rid of this funky guy right here. I'm going to need that room. Okay, so now what do I have? Sine of A times sine of A is going to be the sine squared of A over sine of A plus cosine squared of A over sine of A. And I'm going to tell you right now, ladies and gentlemen, the Pythagorean identity is going to come up multiple times. So now I can add these fractions because we have the like denominator. So let's add those fractions. And what do I have on top? I have sine squared of a plus cosine squared of a over sine of a. Oh. What's the sine squared of a plus cosine squared of a? You betcha. That's 1 over sine of a. And that does indeed equal my right side of cosecant of a. Bam, as desired. All righty. Let's do another example. Okay, I'm going to bypass 3 right now, and I'm going to go jump right to 4. Just to make sure that we have enough time to do some problems on the back of this assignment. All right, so I want to show that this left side is equal to the right side. Step number 1, write all of these in terms of sine and cosine. Extend my page a little bit. 1 over cosine of a minus sine of a over cosine of a. All right. What am I going to do? I'm going to add those guys because I have like denominators. It didn't look like it, but I do. And what do I have here? I have 1 minus sine of a over cosine of a. How in the world am I going to get here? Well, like I said, I've done this proof multiple times before. I know what to do, and so you're just going to write these notes down. What I'm going to do here is I'm going to multiply this whole thing by 1. I'm going to multiply it by cosine of a over cosine of a. Now what do I have? I have on the top, I have parentheses 1 minus sine of a times cosine of a. Don't multiply through that. Over cosine squared of a. Well, what do I want to do here? Well, what I'm going to do is I want to get rid of, I want to find out where do I want to end up. I want to end up at cosine of a over 1 plus sine of a. That's where I want to end up. Okay, so I want to get something to cancel here. I want to leave that guy. Oh, I know what I'll do. I'm going to make sure I stay that in a parentheses. I'm going to write, instead of cosine squared of a, what am I going to do? I'm going to write that as 1 minus sine squared of a. Okay, so these don't cancel, but guess what? This, the bottom now, is a difference of squares because 1 is indeed 1 squared. So now I'm going to rewrite this as 1. I'm going to just rewrite the numerator here. I'm going to write that as cosine A, and it's kind of a funky little C right there. I'm going to rewrite him here. Cosine of A over. Now I'm going to factor this. This is A squared minus B squared. And this, what does this factor to? This factors to 1 minus sine of A. Ooh, that's nice. Times 1 plus sine of A. I have difference of squares. A minus B times A plus B is A squared minus B squared. Now look. Oh, guess what? This cancels with that. So what do I have? You betcha. Cosine of A over 1 plus sine of A, as desired. All righty. as desired, ladies and gentlemen. Again, can you pick out the correct steps? Or if I threw in an incorrect step, if you have these notes written down, the Google form assessment is going to be easy. Let's do, I'm at about 15 minutes. I think I have time for 2 more examples. I'm going to do this guy right here, which is pretty easy. I'm going to do number 5. Keep in mind, I want to start with left and with right. Step number 1, write everything in terms of sine or cosine. This is going to be cosecant is 1 over sine plus 1 over 1 over sine of A minus 1. And what am I going to do? So here I have a complex rational. We've talked about complex rationals a lot. How do I get rid of that complex rational? I'm going to multiply this thing by 1 in the form of sine of A over sine of A, which is just 1. Now I'm going to take and I'm going to go, and I'm going to go do the distributive property here. And what do I have? Sine of A over 1 over sine of A is 1. Sine of A times 1 is plus sine of A. Whoa, 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 whoa. Sine of A times 1 over sine is 1. Sine of A times negative is 1 over 1 minus sine of A. Oh, guess what, ladies and gentlemen? That's exactly what I wanted. As desired. As desired. Yes, some of these are going to be that straightforward. So just be careful when you're looking at the solutions here. Okay, let's jump down here and do number 7, and we're going to end up with number 7 because this, I want to show that whole thing there is equal to cosine. I don't think. Let's try it. Okay, it's already written everything in terms of sine and cosine. So what I'm going to do here, hey, what is sine squared? Isn't sine squared 1 minus cosine squared of A? You betcha. Over 1 plus cosine of A. All right. So what is 1 minus sine squared? Cosine squared is sine squared. And look what I have here. It's hard to see this. Again, I have this difference of squares. So this is going to be 1 minus, in big fraction, 1 minus cosine of A times 1 plus cosine of A over 1 plus cosine of A. Oh, this one is going to be easy too. Looks difficult, but look what's happening here. Now, since I factored that, I wrote sine squared as this rascal. I factored that because that's a difference of squares to 1 minus cosine of A times 1 plus cosine of A. And now look, this, they cancel. So what do I have? I have 1 minus, parentheses, 1 minus cosine of A, bam, which is equal to 1 minus 1, negative, 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 makes it positive, bam, as desired. Okay, ladies and gentlemen, that's about a 19-minute video. I would take some good notes on that. You're going to have a really creative, kind of difficult Google form, an assessment on Friday. So I will talk to you soon. God bless you.